know that not all functions have an inverse. So there is a simple test, which I'll do a little bit later, but let's just have a look at the function y equals x squared. And if we go back to our mapping idea, that f of x, so y is interchangeable with f of x equals x squared. So we want to try and determine what f to the inverse function, which is f to the minus 1. So f's going to take values here and map them over here according to the rule of just squaring the value. So if I put the value 2 here, it will map it over to 4. If I put 0, it will map it over to 0. If I put negative 3 there, it will map it over to 9. Okay, because it's going to square each of those values. And there is an infinite number of possibilities there. So that's just 3 of them. All right, now you say, well, we want to find the inverse of this function. What function is going to take each of these points and bring them back? And you'll instinctively probably say, well, what's the opposite of squaring? The opposite of squaring is to find the square root. And so you say, well, possibly the square root of x may be the inverse. If we go up here, the inverse should take each of these points back to their original. And if we put in 4 into this function, we get square root of 4, which is 2. So that one's correct. If we put in 0, we got the square root of 0, we get back to 0, so that one is true. If we put 9 in there, the square root of 9, because we've got no sign there, will be just positive 3. It won't get us back to negative 3. We would have to have a negative there to get us back to negative 3. So the square root of x is always going to be positive for x is greater than or equal to 0. So this is going to be positive. We're never going to get back there. So the square root of x is not the inverse. So y equals x squared, or f of x equals x squared, has no inverse, because there is no single function that will take every point. It'll take some of the points back, but it won't take that point from 9 back to negative 3. So we've got to come up with some sort of simple way of doing a test to see whether functions have inverses. So if we look at the graph of y equals x squared, and now you're very proficient at drawing these, so y equals x squared. Turns out that we have a thing to test for, we have a test for inverses, so it's called the horizontal. We had the vertical line test to test whether it is a function. So the horizontal line test for inverse. So the test is if you can draw a horizontal line through the graph, and if it cuts the graph in 2 positions, then no inverse. Cuts graph twice. And that will mean no inverse. Alright, so that's the horizontal line test for inverses. And you need to know that if you can draw a horizontal line parallel to the x-axis, and if it cuts the graph twice, therefore the function has no inverse.